Discover how MIT's groundbreaking solar-powered desalination system is transforming access to clean, affordable water worldwide without the need for batteries. In this video, we'll explore how this innovative setup provides clean water to remote areas by adapting to sunlight changes in real time. A new solar-powered desalination system maximizes drinking water production even when solar radiation is low. This innovative solution was developed by engineers at the Massachusetts Institute of Technology, MIT. As sunlight increases throughout the day, the system speeds up desalination and automatically adjusts to sudden changes in sunlight levels. For example, slowing down when a cloud passes by or accelerating when the sky clears. Because the system reacts quickly to slight changes in sunlight, it maximizes the utility of photovoltaic (PV) energy, producing substantial amounts of clean water despite the fluctuations in solar radiation throughout the day, as MIT explained. Unlike other solar-powered desalination projects, MIT's system doesn't require energy storage batteries or supplemental power from, for instance, the electrical grid. The engineers tested a prototype for 6 months within a small community, drawing from groundwater wells in New Mexico and working in variable weather conditions and water types. On average, the system used over 94% of the electricity generated by photovoltaic modules to produce up to 5,000 liters of water daily, even with significant fluctuations in weather and sunlight. For more information and documents, subscribe to erevolutionhub. Producing potable water using renewable sources without storage batteries is a big challenge, and we did it, commented Amos Winter, a professor of mechanical engineering and director of MIT's Global Engineering and Research, GEAR Center. The system is tailored for desalinating brackish groundwater, a salty water source found in underground basins that is more prevalent than freshwater aquifers. Researchers view brackish water as an untapped source of potential drinking water, particularly as freshwater supplies are increasingly strained in parts of the world. This new renewable, battery-free system could provide crucial resources like drinking water at low cost, especially in rural and inland communities with limited access to seawater and the power grid, according to the authors of the study published in Nature Water. Unfortunately, groundwater is becoming increasingly saline due to climate change. This technology could deliver clean water sustainably and affordably worldwide, said Jonathan Bassett, a PhD candidate in mechanical engineering at MIT. Pumping and flow. The new system builds on a previous project that MIT engineers introduced earlier this year, based on a batch-flexible electrodialysis system. Electrodialysis and reverse osmosis are two main methods used to desalinate brackish water. Reverse osmosis uses pressure to push salt water through a membrane, filtering out salts, while electrodialysis applies an electric field to remove saline ions as water is pumped through a stack of ion exchange membranes. Scientists have attempted to power both methods using renewable sources. However, this has proven especially difficult for reverse osmosis systems, which traditionally operate at a constant power level, incompatible with naturally variable energy sources like sunlight. MIT engineers, therefore, focused on electrodialysis, aiming to create a more flexible system capable of responding to variations in solar energy. In their earlier design, the innovation included a model-based control system that uses sensor readings from each component, water pumps, ion exchange membranes, PV modules, to predict the optimal speed for pumping water through the membrane stack and the voltage to apply to maximize the amount of salt extracted from the water. In initial field tests, the team was able to adjust water production based on natural solar variations, directly using 77% of the available electricity from PV panels, 91% more efficient than traditional solar-powered electrodialysis systems. In the early tests a few months ago, we could only recalculate every 3 minutes, and in that time, a cloud could come and literally block the sun, Winter explained, noting that with more precise sensors, the results could have been even better. Solar commands. In their latest work, the researchers reduced the system's response time to a fraction of a second. The new system can now update the desalination rate 3 to 5 times per second. This faster response time enables the system to adjust closely to sunlight variations throughout the day without relying on backup power supplies. The key to this more flexible desalination system is a simpler control strategy. If the PV modules generate more energy than the system is using, the controller automatically instructs the system to increase pumping, pushing more water through the electrodialysis stacks. Simultaneously, the system diverts some of the additional solar energy by increasing the current to the membrane stack, extracting more salt from the faster-flowing water. The engineers incorporated this new control strategy into a fully automated system designed to desalinate brackish groundwater at a daily volume, sufficient to supply a small community of around 3,000 people. The system was tested for 6 months at various wells at the Brackish Groundwater National Research Facility in Alamogordo, New Mexico. Throughout the testing period, the prototype operated under a wide range of solar conditions, using over 94% of solar panel energy to power desalination directly. Compared to traditional solar desalination system design, we've reduced the required battery capacity by nearly 100%, Winter stated. The engineers now plan to test and scale the system further, hoping to provide low-cost, fully solar-powered drinking water to larger communities and even entire towns. The research team plans to launch a startup based on their technology in the coming months. For those interested in learning more about this system and the team's future plans, check out the information and supporting documents below. And don't forget to leave a comment. What do you think of this new technology? Would you like to see it implemented in your community?